Okay, this time we're going to talk about synthetic division. So this is part 2 of dividing polynomials. When you have synthetic divisions, that first row that is shown in blue here is your coefficients of your dividend. So you'll see like a polynomial that has a bunch of terms in it for the most part. You only want the coefficients, no variables. What goes next to it and this backwards L shape is going to be your divisor. Since we're talking about polynomials, you may have something that looks like x minus 5, so your divisor is actually going to be the opposite number. So basically you're taking whatever is given here and you're setting it equal to 0, and that is what will replace your variable. So that's what's going to be my divisor. So in this instance, it will be a positive 5 that goes in the divisor place, because 5 minus 5 is 0. When I am using synthetic division, I want to make sure that my divisor has a leading coefficient of 1. And that 1 is represented by what's in front of this variable. So x minus 5 is really 1x minus 5. When I'm doing my synthetic division, the first row that I talked about with the coefficients, I'm going to bring down that first number. That's how I start the process. So I always bring down that first number. When I do that, then I'm going to take that number and I'm going to multiply times the divisor. The answer to that will go right above the line. And then I will add down. So let me demonstrate how it works with an actual problem. And also, as I stated in writing here, once I get that answer, I want to make sure I put my variables back in. So this is what it's going to look like. The first thing I do is I set up my backwards L, which is where my divisor is going to go, and then I just draw a line underneath it. So my divisor, again, is after the division sign. My dividend is what's before the division sign. So make sure you recall the terminology. For my divisor, I would not put the entire expression k plus 1. What I would put is negative 1. And that came from me setting k plus 1 equal to 0 and solving for k. So I'm doing the inverse, and k is actually negative 1. So whatever this answer is, that's what your divisor is going to be. So the next thing I want to do is I want to look at my dividend, and I want to make sure it's in standard form. So with my highest exponent, counting down 3, 2, 1, and then there's not an exponent, and I only want to write the coefficient. So the coefficient is the number that's in front of the variable as well as the constant. So 1 and the sign, 2, 11, and 12. So this is how you get started. The first step is always take your first term, the coefficient, and bring it down. So whatever that number is, here it happens to be 1, but it can be anything. Bring that down underneath your line. Now, everything that's underneath the line will multiply times the divisor. So we're going to multiply times the divisor if it falls below the line. The answer to that will go above the line, and then we're going to add vertically. So this is what it looks like. What's below the line? 1 multiplied times the divisor, negative 1. So 1 times negative 1 is negative 1. Place that answer above the line. And now you take those numbers and add them. 2 plus negative 1 is 1. Take this number below, multiply it. 1 times negative 1 again is negative 1. Add these two numbers, 11 plus negative 1, positive 10. Then you want to take the 10, multiply it times negative 1. You end up with negative 10. And then 12 minus 10 is going to give you a positive 2. Your last term, if it has a number in it, that is your remainder. And again, this is helpful because you're not finished. You may think you're finished, but you actually have to add your variables back in. Also, if I have a remainder, that tells me that this divisor is not one of the factors of this polynomial. So I am going to look back at my original problem, my original dividend, and I see I have the variable k to the third power. So if I have it starting at the third power, my new answer, my quotient, is going to go down 1 degree. I'm still using that same variable, and these are my new coefficients. So I have 1k squared plus 1k plus 10 plus, because I don't have any minus or negative signs, so I'm just using plus signs. And this is my remainder. The remainder is always in fraction form. So 2 over my dividend, k plus 1. So this is my final answer. That's my quotient for this particular problem when I'm dividing it. K squared plus k plus 10 plus 2 over k plus 1. This is how you would divide using the synthetic method or using synthetic division. All right, so let's try one more. Again, I'm trying to determine what I would put in this backwards L shape. So for me, that's my divisor. And the divisor is based off of what can I put in the place of this variable to make this equal 0. If you can't tell automatically that it's the opposite sign, which is positive 7, then set this equal to 0. So r minus 7 equals 0. The inverse of negative 7 is positive 7. And so when I solve for r is simply 7. Now, if I'm looking at my dividend, I notice that it is not in standard form. So I want to rewrite it in standard form so I don't get confused. So r to the fourth is my first term. I notice I don't have an r to the third power. So what I'm going to do is put in a 0 placeholder. I do that all the time. Make sure that you account for that missing variable. And then let's go to the next one, or missing exponent. Okay, and then we have an 18r. And finally, our constant is negative 28. I no longer need that. So when I'm writing it in synthetic form, synthetic division form, I only want the coefficients. I don't want the variables. So the coefficient for r to the fourth is 1. Coefficient for r cubed, I put in a 0, negative 51, 18, and negative 28. First step, always take the first term's coefficient and bring it down. Whatever that is, I am going to multiply it times the divisor. So 1 times 7. Take that answer and I place it right above the line. Everything above the line will be added down. 0 plus 7 is 7. 7 times 7, positive 49. Negative 51 plus 49 is negative 2. Negative 2 times 7, negative 14. 18 minus 14, positive 4. 4 times 7 is positive 28. So negative 28 plus 28 leaves me with 0. So if that happens, that means that I don't have a remainder. And that also means that this divisor is, in fact, a factor of this polynomial. Okay, so now, again, you would think you're done, but you're not, because you have to go back and put the variables in. So I'm looking at the original variables I'm given. I'm not given x, so I'm going to use the variables that's given, which is r. I count down 1 degree less than what's already shown. So if this is r to the fourth, my first coefficient just happens to be 1, so it's going to be 1 r cubed. Then I go to the next coefficient, which is 7, and I count down with my exponents, r squared, negative 2, r, positive 4, it doesn't have a variable, and since I don't have a remainder, I do not have to put 0 over the divisor. This is my answer. So r cubed plus 7r squared minus 2r plus 4 is the answer once you go back and rewrite with your variables. So this, what's underneath your line, just so you know, those are your coefficients for your quotient, as well as the constant. So coefficient and constant. That's what that information is used for. There's a 1 there, 7, negative 2, 4. So understand your terminology. So when we're talking about coefficients, constants, and dividends, divisors, you know exactly what we're referring to, okay? And this is easier, the synthetic, but make sure in some cases you have to use your long division.